Well, we'll go into a few examples. This one is at Razor Ranch in Denton. I mentioned that if you can get your concentrated flow into a swell before it gets into a bioretention area, then you're going to benefit from that. This one's actually a very long swell, so you're going to have a lot of the sediment and other materials settle out before it even gets into the bioretention here. This one also has a very large water quality pond. Obviously, they're not going to have enough room to meet all the water quality requirements of such a large development with just a few of these bioretention areas. But this is one of the first applications in the area, and from what I understand, it's working really well. I haven't seen any sample data, but from what I understand, Leslie, I know you've been in touch with them.
Yeah, they've been to most of our presentations where we've talked about their establishment, and we haven't heard any issues or problems concerning bioretentions. Any extreme maintenance, nothing having to replace the soil.
And it looks nice too. So this photo is actually fairly recent. You can see you're not seeing any kind of real erosion. They've got this little riprap forebay here, so it's spread out fairly well as it makes its way across and downstream. And it's just standard lawn maintenance, really. They have kind of mild slopes. You don't want these things to have 2-to-1 slopes and be your standard ditch where it's going to be impossible to keep it maintained. You can see that the planting plans, you have a very large variety of plants that you can use. And again, I'll get back to the zones that Leslie mentioned earlier. You want to make sure that you're planting the right things in the right places. This is post-storm event. I'm not sure how long after a storm. Hopefully only about 15 or 30 minutes. But you do have some ponding there, and that's to be expected. But again, as long as this is going to drain within that 24-hour time period, you should not have any problems with mosquitoes. I don't know, this summer I have problems with mosquitoes even where it's dry on high ground, so it's going to be tough either way you look at it. Another application, this is more of a, not as aesthetic, but more of a general purpose application at the Denton Municipal Airport, where they did have quite a bit of room to apply that there. One thing that this is missing, is we don't have the stone diaphragm around the perimeter. And I believe the reason is it's far enough away from that direct runoff that it is spread out. So they're actually collecting a lot of that sediment-laden water, pollutant-laden water through the grass areas before it reaches the actual bioretention bed.
And that's very early in the establishment period, so the plants haven't really had a chance to grow, or they're pretty small still.
This one I can talk to with a little more detail. This is a Elmwood Athletic Complex for the city of Dallas. We have a total of 6 bioretention basins on this project. It is right now it's about 75% complete. The last remaining items we have to complete on this project are it's a large retaining wall along a hill. Actually establishing all the grass. We're running out of time to get all this turf placed. We'll probably just have the first 6 fields planted by the end of the planting season this year. So we're going to have a challenge of a circle where we have bioretention basins here. They look tiny. They're actually quite large. These are all international size fields. The total acreage of the site is 82 acres. And we're meeting the ISO criteria for water quality with this network of bioretention systems. The challenge we had with this project is it's on an old landfill, and TCEQ would not allow us to infiltrate stormwater into the waste layer below. So we had to look at it from a different perspective. We wanted to get water in and out as quickly as possible. And to do that, we started looking at some of the manufactured systems of rain tank. And what the rain tank allowed us to do versus just having a small slotted PVC underdrain, it allowed us to greatly increase the capacity for flow of these systems. And what's been shown is you have two schools of thought. One is that if you have slow infiltration through the systems, you're going to get the maximum amount of treatment. And that's not necessarily the case. If you have the right soil media, you can greatly increase that infiltration rate just as long as you're controlling the outflow rate at your discharge and meeting retention requirements. You still get that maximum amount of treatment. Most of it really happens right with that first flush, right when you're going through the system. This system, at completion, before operation, is generally about 100 inches per hour that it can process. And what happens is you get to really concentrate that area of filter media. So we may have a long swell, but we don't have that filter media extending all the way back. We just have it all compartmentalized here at the end. So it really reduces your cost. You're just looking at, in some cases, you're reducing that filter media requirement by 70 to 80%. And it relies a lot on the configuration and the grading of your site to make sure that works. But this is showing our section that we used. Again, we have these plastic rain tanks, and I think we threw some pictures in of those tanks. And beyond that, very, very similar to the sections that Leslie showed earlier. My lasers kind of died on here. But it's a real high capacity system. And when you start talking about clogging, when you have a high capacity system, you can move that water through really quickly. If you do have the clogging, let's say you reduce your infiltration rate by 50%, that's a very clogged system. But still, you're looking at a capacity of 40 to 50 inches per hour. So it's going to take a very long time for this thing to be ineffective. If you drop that down from 100 to 50, you're still capturing the same area. You're still essentially getting at least 80% of the treatment capacity. So it takes a long time for that to build up. And that's with zero maintenance. That's without any kind of replacement of the top layer at all. And I reiterate that regular maintenance, looking at your mulch layer, making sure that you don't have a lot of debris on it, and cleaning that out regularly, replacing it regularly, that's going to be your ultimate defense after you make sure you spread out the water going into the system and reduce the set of floating going into it. This is a close-up of one of the systems. And actually, our systems are tied together, and the reasoning for that is we have a large irrigation pond. It's located to the south, so we're trying to collect all that, and we're going to reapply it to the fields. So we essentially have kind of a treatment train systems here. This is actually a system being installed. I think the excavation work was done in a day, and the next day the workers came out and started installing the tank system itself. You can see it just basically sits in a geotextile wrap that's backfilled with filter media, wrapped up, and then covered with the engineered soil on top. This is downstream end, that's the grate for the overflow. And this one, I believe, is I think it's 7.5 inches from the base of the bioretention to the overflow. Those are the tanks themselves, like milk crates, really very light, easy to move around. The contractor that we had installing them had never installed the systems before. They've been having a problem. Went in very easily and very quickly. This is some of the engineer backfill going in.
Those tanks replace your planting soil, or whatever you want to call it?
Actually, the way I look at it, it creates a high infiltration rate zone right at the center of your bioretention basin. It's like I look at it as the motor to get everything through the system.
Okay, but it's not filtering anything.
It is. The backfill. No, you're right. The filter is the media around.
Yeah, it just increases your
increases
ability to
the
move flow through it.
Correct. Another application is Merritt Road. What time is it? Make sure I know. Okay. Merritt Road, this project, I believe, is going under construction in about 1 month. It actually may be under construction now. I know it's been. This one, we're essentially using a large network of bioretention swells. When we first conceived it, we were going to do the enhanced swells where we had the infiltration by media along the entire alignment. You can see we have 3,600 feet of swells. So we really wanted to find a way that we could cut back on that filtration media along those long alignments. So we looked at a similar system that we're using on the soccer complex, where we wanted to sandwich that down and create an area that had a high infiltration capacity. And so we kind of got the benefit of very long reaches of vegetated swell where we had a lot of settlement capacity before it even got to the system. But even to avoid potential sediment getting into it, we created these rock filter berm basins, essentially, so it's going to spread it out as it gets into it. This is the actual bioretention treatment area right here. So you can see that's very small compared to our total length is 3,500. I think we had 5 areas along that 3,600 feet, and we still were able to meet the treatment requirements of ISWIM. Similar section there, it shows our max ponding depth. This one was actually 1.2 feet. We had 4-to-1 side slopes. Obviously, this is going to be a grass median. They're going to need to maintain it quite regularly. But that's essentially the same design that we used on the soccer complex. That should be going underground probably within the next 12 months. It's a nice little road application.
What's that
section here?
white void area over the top of your rain tank that comes up to the vegetative swell surface?
That's a inspection port. That's an inspection port and an overflow port. Typically you want to have, I'm not going to call it the spacing on the inspection ports because the ones I've had, we only had one, but you use about a 12-inch PVC for those.
Okay, so that's just a very localized little area.
Yeah, and when you have the longer runs of it, you'll have these 6-inch PVC pipes, and Leslie mentioned you want those setting up above the maximum ponding depth. Those are spaced out, I think you said 50 feet. So once you get over 50 feet.
It's kind of like your clean outs.
Yeah, that way, when you have the frequent events, you have the ponding, you don't have it going just to one discharge point. And then you have the potential of your mulch possibly spreading out and regrouping around that area, then you got to go back in, rake it back out, or put more in. If you have the space appropriately, then you have the right hydraulics to where it makes it even. This is the best word for it.
Is that a grate on top of it to keep out larger debris or anything?
It is. It's a little
Or is it
seal.
just not-
No, it's a slotted grate. Yeah. Any other questions? I think we're right on time. Thank y'all for coming out. All right, let me ask, do you guys have any bioretention systems being designed right now that you're taking a look at? Proposed? Potential?
So these areas, are they supposed to be designed where they're not mowed at all? They're just natural?
Ideally. Yeah, you really just want to be mowing the outside bands and again keeping them flat. And if you use the right materials inside the system, you're really just looking at kind of going in and weeding and pruning.
Yeah, especially that mulch area, you don't want, a heavy lawnmower or riding mower in there, because that's going to compact the soil, and that's going to lessen your infiltration.
Just to ask, does that Razor Ranch will look like Bermuda grass?
Right, that one is grass.
Mhm. Yeah, and I'll go back to this operation and maintenance provision. It's heavy equipment will never be driven over the bioretention cell. So they get real specific about what types of equipment can be in there. So ideally, you want it to where you just got manpower in there, keeping it clean.
How do you clean those the crate areas? How do you clean those, or are they not expected to have a native cleaning?
They're not really, but you do have the maintenance ports to where you can flush them out.
Okay.
And that's really through your outlet pipe. You usually have, I think, 24-inch pipe is typically what I've seen on mine. So you can flush it out through the outlet. But the ones that have been installed over the past 2-3 years, really, you haven't seen that much clogging or loss of efficiency. All right. Thanks again, everyone.